Okay, hello everyone. We're gonna start our second session, which is PowerPoint number 2 or chapter 2, and it's about describing and exploring data, part B. So let's just upload. Okay. Okay. Once again, I encourage you to stay on top of your quizzes and do your SPSS assignments weekly. And please let me know if you have any questions or concern. So last week we talked about chapter 1, the basic concepts, and now we're going over chapter 2, which is describing and exploring data, part B. So chapter 1 and 2 are together. Last week we did part A, now part B today. Your quiz 2 starts with this presentation. So when we finish, you're ready to take your quiz 2 and do your second SPSS assignments. So we're going to talk about variability and reliability in test construction briefly, because this chapter is about variance. Again, this is not research method class, but one way to know about the quality of your questions in a test or in any kind of measurements that you're creating or inventories, is to know the reliability and validity of not just your questions, but your entire test. Covariances tells us about the variability and in this case quality of each question. And we'll talk about that. So what is variability? It's the degree of dispersion of scores in a set of scores or data. Dispersion means spreading. So we're talking about the normal distribution right here, and we're talking about this spreading the scores or dispersion of the scores under these bell shape. Are they in the middle? Are they on the right side or the left sides, or where are they at? Variability is about variety, okay? Where the scores are. We're going to talk about range, very simple. Is the difference between the highest and lowest score plus 1. In mathematics, they don't have 1. They just say the difference between highest and lowest, but in statistics, we add 1. And we're also going to talk about standard deviation and variance, which is the average difference of each score from the mean. As you can see, these lines at the bottom, these or on top, these are standard deviation, means fixed distance from the mean. In this case, it's just 1 point. You go up, it's positive. You go down to the left, it's negative. Or here, at the bottom, you can see that standard deviation is 1. And this is one of the application of these materials. For example, by looking at this distribution, you can see that that the scores are low. And you can see right in the middle, majority of the students score 50s and 60s. And not too many at the very end have 80s and 90s and 100. This is a result of poor attendance. This is research data which shows the poor attendance from 665 students. As you can see that. On the same token, good attendance, you will see right in the middle, the majority of students score 70s and 80s, and we have some 90s, even good 90s, 95s, and even 100. So this is the purpose of this distribution and this variability of the scores, variety, how they change. They tells us where our class stands, our students are. Are they all in the middle, average, or to the right, score high, or to the left? Variability is a measure of dispersion or spreading of scores around the mean, and has two purposes. Number one, describes the distribution, like I just described two distribution. And number two, how well an individual score or group of scores represents the entire distribution. The measures of variabilities are range, interquartile range, semi-interquartile range, and standard deviation and variance. So we're going to talk about these different measures of variability. The range, like I mentioned, is very simple. You have a bunch of number called data, and you want to, if you want to find the range of this data, you need to look for the highest number and subtract that from the lowest number. In this case, the data that you see I circled in red, the highest number is 10, the lowest is 2, so 10 minus 2 is 8, plus 1, don't forget that plus 1, which gives you range of 9. But if you have a fraction like decimal, then the way you measure your range is a little different. And it goes by the difference between the upper real limit of a highest number and the lower minus the lower, the real limit of the lowest number. The difference between these two. So what is upper real limit and what is lower real limit? Like I said, if you have a whole number, then you only add, if you measure in the upper real limit number, you add 0.5 to that number. That would be the upper real limit of that number. For example, if the whole number is 2, the upper real limit will be 2.5 for that. On the same token, the lower real limit, you go down half a point, so will be 1.5, the lower real limit. But if you have fraction, you can see on top right, I have L on the right and U on the left. So for 2, number 2, if your upper real limit, if your number is 2 all the way to 2.4, that means 2.1, 2.2, 2.3, 2.4, anything in between, then your upper real limit will be 2.5 because it's less than 2.5. However, at the bottom, if your number is 2.5 or higher, like 2.5, 2.6, 2.7, 2.8, 2.9, then your upper real limit will get up to 3. That's for fraction. And then on the same token, your lower real limit, if your number is between 2 to 2.4, your lower real limit will be 1.5. And if it's between 2.5 to 2.9, under 3, then your lower real limit will be, let me just change that, will be 2. So let me just change this draw. Okay, so this is what I said. So okay, the upper real limit for 2 to 2.5, we just put U here and U here, and then the lower real limit, put L here, L here. So the difference, for example, if you, at the bottom again, the number is 10, the upper real limit of 10 will be 10.5. And the lowest number is 2. The lower real limit of the lowest number, which is 2, is 1.5. Also will be 9. 10.5 minus 1. So keep in mind, if you want to use the bottom technique, then there is no minus 1, I mean plus 1. But if you use the top one, you have to add 1 to it. The top one, the difference between highest number minus lowest number plus 1. But the bottom one, if you have a fraction, you wanted to use upper real limit and the lower real limit. You add 0.5 to 10, and the lowest number is going to have the lowest real limit, which is 1.5 of that. Okay, so as for that, the interquartile range, I know is a mouthful, but it's really easy. Quartile means quarter, so this is your distribution, that normal distribution, and if we, right there, if you draw a line in the middle, that's your measures of central tendency and mean, median, mode. Then you have 2 halves, 50% on right, 50% on left. With that in mind, if you divide the 50%, you get 25% on each. So you have 4 quartiles, each 25%. The first quartile, right there, I put 1. (25%), and the second quartile, and third quartile, and the fourth quartile. So these are the interquartile. Just 1 second. I want to check something quickly. Okay. So interquartile range, okay, so here's the better picture at the bottom. So you can see that each one of those quartile is 25%. So interquartile range is the difference between third quartile, whatever number is there, and the first quartile, Q3 minus Q1. In other words, this is your Q3 right there. Whatever number you see at that bottom, and we're going to put some number at that bottom where that black circle is, and Q1, whatever the differences are, like whatever, if one of them is 8, one of them is 3, 8 minus 3, it's the interquartile range. Interquartile range is the range covered by the middle 50% of the distribution. So you can see that Q3 minus Q1, it gives us the area in the middle. Again, this is not too popular range, but we use it in research. There are some examples here. You can go over the PowerPoints and read those examples in some kind of research. When we use longitudinal study long term, because the data keep coming, it'll constantly affect our research. So we use interquartile range, for example, because we only focus on the middle 50%. That's one of the use and all that. That's the purpose of that. Interquartile range is the distance between the third quartile and the first quartile. Assesses the distance between the scores at the 75th and 25th percentile rank. And there it is. Again, those the 75th percentile and 25th percentile. In other words, that gray area, the shaded area, it tells you that's where we're interested. We wanted to measure that. Tell us what's the area, that area, how do you measure that? So if you look at that red line I drew right there at the bottom, and we start putting some number there, the upper half, lower half, okay? So if you put those numbers, and if I tell you that measure what is the Q3? Right there in the middle, your mean median mode, it says median is in the middle. So again, the other right and left are 50-50. So if you draw a line like I did with the red line, in the middle, that is your Q3 on the right and Q1 in the middle. So let's look at Q1. That line is between 64 and 64. Those are scores, by the way, like two people score 64. So what's the score between 64 and 64? It's 64. The mean for those two numbers is the same, 64. You can see it at the bottom, 64 plus 64 divided 2 is equal. On the right, we write through the two different numbers, 77 and 81, and we want to know what's the mean. That tells us where that red line is. 77 plus 81 is that divided by 2 is 79. So 79 is third quartile, and 64 is the first. So 79 in the middle interquartile range is 79 minus 64, which is 15. Again, we don't have too much use for these nowadays. but it's something to know. That's another one. As you can see, that's the bottom of the distribution, normal distribution. I draw a line on top so you can understand it better. Once again, this is first quartile, second quartile. So you have, for your quiz, I give you the first quartile and third quartile, and I say, what is the interquartile range here? All you have to do, subtract them. 47 minus 36, that's your interquartile range. And what is semi-interquartile range? Very simple. Once you got your interquartile range, divide it by half. Whatever your interquartile range is, that means you have to calculate your interquartile range. Whatever it is, divided by 2, it gives you semi-interquartile range. We use that when we don't know the highest score and lowest score in a distribution, because we keep adding to the sample. Then it's better to use semi-interquartile range. That's the research technique they use. It's not too popular nowadays. Just something to know if you heard. Semi-interquartile range is half or half of the interquartile range. It's used when our data are open-ended. In research, we continue to receive more extreme numbers. It is lowest measures of variability. So you see, it's a low level of measurement, in this case, range. And then we use it when we have extreme numbers. This way, we don't use those extreme numbers. We just stick with the middle. That's a better measurement. So that was range, interquartile range, and semi-interquartile. Now let's talk about, on top blue, it says we're going to talk about the standard deviation and variance. And this is the hardest part of this chapter. Well, first, before that, again, last time we talked about population and sample. They're pretty much the same. We said sample is just subset, a small section of a population, but it contains all the information. So if you wanted to measure the standard deviation or variance for population, you see those calculations in blue for a circle POP, that stands for population. And at the bottom, that when it says sample, I circle that. Those are for little formula. I call them little guys. But again, you might ask, what's the purpose of learning these? Like I said earlier, when you have a bunch of numbers, in this case, X, which is our scores, when we have 4 numbers. Now, these are scores, and the score comes from doing something, measuring something, assuming that, and then again, it comes from people. People get scores, number of participants. That tells us that we have 4 participants. But let's say, trying to, make believe, we give it life to those numbers. Let's say we got 4 people and we give them an essay question. And the maximum you can make out of that essay question is 5. So you can look at the first person got 1 out of 5, the second person 2 out of 5, third person 4 out of 5, and 5 person 5 out of 5. But we are looking for the whole purpose of calculating like standard deviation and variance. In variance, the whole purpose of calculating variance tells us about quality of question on that question. So if we have in test construction, when we have, let's say 10, 15, 20, hundreds, 2,000 items in our test, and you wanted to get rid of some of them, how do you know which one to discard? The one, you discard the one with the lowest variance. So you calculate the variance. Of course, SPSS does it with just the tip of your finger. It tells you what's the variance, and then you go through them, and the one with low variance are low quality. Then you keep the one with high variance, high quality items. That's the purpose of this in test construction. So we're going to do one, just one, that one. Once you learn how to do this manually for the quiz purposes and your midterm exam. And then I'm going to show you how to use SPSS to conduct like same applications, same statistics with many. Let's say we have 10 people, and then each take a test with 6 items, 5 items, 10 items. And you just enter the data into your SPSS, and it tells you which one has the highest variance. Standard deviation, it tells us about the fixed distances each score has from the mean. Like they could be positive or negative. Like you can tell that the first person got 1. Well, the mean here, it'll be like something, maybe like 2.5 or something, 2.5 something. But so you can see the guy who scored 4 and 5, people who score 4 and 5, they are above the mean, and people who got 1 and 2 are below the mean. So the measurement under the mean, the distribution, is fixed distance, which is called standard deviation. If you square the standard deviation value, you get the variance. So in reality, the calculations are the same. If I ask you, now this is very important, you got to pay attention. If I say we have a distribution, it doesn't matter if I say that distribution comes from population or sample. If I say we have a distribution and it has a standard deviation of 2, what is the variance for this distribution? So you know that you immediately have to square that. As you can see, that whether is sigma, that blue one, that little like a Hershey kiss, and sigma square. These two symbols, you need to know these immediately, the symbols. These are the alphabet of statistics. So sigma is a standard deviation of the sample. When you square it, is the variance. And at the bottom, okay, the blue is population, sorry. But for the sample, S is standard deviation for the sample, and S squared is the variance for the sample. So if I say the standard deviation for sample or population is 2, what would be the variance? There is no need to calculate anything. You just square it. If I say standard deviation is 3, what is the variance? Square the 3, 9. On the same token, if I say we have this distribution and the variance is 16, what is the standard deviation? Then the square root of that number the square root of variance, if I give you, will be standard deviation. So in this case, the square root of 16, which is variance, will be 4. That is the standard deviation. Or square root of 9 is 3. So that's how it is. But in order to use this formula, Um, you need to, again, if you look at them, look at the formula, variance is SS over N, a standard deviation, or is, let's say for the top one, SS, the square root of SS over N. And at the bottom, again, SS square variance is SS divided by N minus 1. N minus 1, also called degrees of freedom, or DF. DF is related to N, sample size. So whatever your sample size is, you take away 1 from it, will be DF, if you have 1 sample. So DF and N minus 1 are the same thing. So SS divided by DF variance. And then S will be square root of that. On the top one, variance, SS divided by N, population, the standard deviation of population, square root of that. At the bottom one, for sample, variance, SS square, is SS divided by DF. So in this case, our DF is N minus 1. N is 4, because we have 4 scores, and the scores come from people. So we have 4 people, there are 4 participants, and that's the score from each. So DF is N minus 1. 4 minus 1 is 3, like I wrote at the bottom. Top, in the middle, right. It says 4 minus 1. DF is N minus 1. So if you look at them, they all have one thing in common, and that is SS. Now, what is SS stands for? That would be the hardest thing for this chapter, to do all these activity and do your quiz too. SS for short means sum of square, but the long definition for it at the bottom, I color code them, and those colors have a meaning. SS stands for sum of square deviation from mean, and this is called definition. Definition of SS. What is SS? Sum of square deviation of mean. So if you look at it, look on top when it says definition, and then I wrote sum of the square deviation from mean. So you see that at the bottom, I have the word sum, S-U-M. On top of that, I have the symbol for sum in statistics. It's sigma. Of squared, that means you squared times itself, or 2, right? So it means the squared means 2. Square multiplied twice by itself. And deviation in red, x minus mu, means distance from mean. So you don't have to write from mean, because we know what deviation is. Deviation is distance from mean. That means x, whatever the x is, minus the mean. That tells you the deviation. Distance of x, that score, okay, from the mean. And we're going to do that calculation. There is another way to calculate the SS, which is called computation, which has a formula. A lot of students find that the computation is easier because it's very straightforward. All you need to know is to what is x squared. So keep in mind the data that you have, and I circle, are x. And if you add a map, which will be 12, then sum Okay, then you can create another set of data, which I have here, okay, right there. So these are the data, x1, 2, 2, 4, 5, 1, 2, 4, 5. You create another set of data called x2, x squared, sorry. That means you square each number, each score. The square of 1 is 1, the square of 2 is 4, the square of 4 is 16, the square of 5 is 25. So if you decided to use the definition formula, as you can see right here, you right here, definition is the arrow. It says sum of a squared deviation from mean. Let's do that. And then we come and we do the same thing with the computation. The computation actually is easier. Let's do that. Computation is sum of x squared. So that means you got to add up all those numbers under the x squared minus square the sum of x. So you need to add up the x here. Sum of x is 12. So you square that, which is 144, divided by n. N is number of participants. Right there again. So that would be 10. And then on the same token, if you want to use the definition, you got to follow that definition, which it says sum of a squared deviation from mean. The reason I wrote that for mean, so you can remember your first task, if you want to use that, calculate the SS by using definition, is to calculate the mean for your distribution. And you see the numbers go backward. 1, 2, 3, 4 at the bottom left side of the computer. So it tells you that first you got to calculate the mean for your data, then do your deviation, means subtract them from the mean that you calculate, then you square that, whatever number you got, and then you sum them up. So it should give you the same number either way you calculate the SS. So let's do it. First task is mean, calculate the mean for the x right there. Mean is sum of x divided by n is 4, and sum of x is 12. 12 divided by 4 is 3. I thought it said 2.5, so 3. So that's mean. Now deviation, is the next column. Distance from mean. The first score is 1. Distance from mean, that means subtract it from mean. 1 minus 3 is negative 2. The second score is 2 minus 3 is negative 1. And the third is 4 minus 3 is 1. And the last is 5 minus 3 is 2. Those are called deviation, distance from mean. So you sum up all those deviations. First of all, you square them, the last column. You square them and square the deviation, as you can see, x minus mean. Then that's deviation, you square it. Negative 2 is 4, negative 1 is 1, 1 is 1, and 2 is 4. Square. Now you sum, right? The last thing, step 4, is sum. Add them up. 4 plus 1 plus 1 plus 4 is 10. So either way, you calculate the SS. Once you calculate the SS, you're home free. Then you can go back to that calculation. If I ask you right on top right side of the screen, if I say, what's the variance? Variance was SS over N. Well, we know the value of SS. We calculated manually. Either way, whether definition or computation, is 10. So you don't have to use both ways, just select one. If you do both ways, then you know for sure it should come out with same number. So SS is 10 divided by 4, which are 4 people, or number of scores. That gives you 2.5. That's variance. A standard deviation for population is a square root of variance. Now you got the variance, just square root of that, which is 1.5558. Sorry. And the sample, for the sample variance, SS squared is SS over DF. Again, SS is 10. DF is n minus 1. That is 4 minus 3 is 1. 4 minus 3 is 3. So that gives you 3.33. That's your variance. And the standard deviation at the bottom will be square root of that. And then again, for your quiz purposes, if I ask you to calculate the DF and I give you the SS and variance, you use that formula right there. But if I ask you what is SS and give you DF, or just give you the sample size, you know how to calculate DF. Just take away 1 from sample. So that would be your DF, and I give you variance, plug them in, gives you score. So this slide is the heart of this chapter. It has almost all the formula that you need before you take this quiz. And you should be ready to take your quizzes. And briefly, I go over a few of them. Calculate the standard deviation. Okay, so we did that. So a sample has 5 scores. Okay, there's 5 scores. We don't know what they are, but it has a mean of 20 and variance of 4. What is sample standard deviation? That's why I said you got to pay attention. All these numbers are for distractions. N is 5, M is 20. I said if I give you the value for variance, which is 4, standard deviation value will be square root of that. So square root of that, they want a standard deviation for the sample, S. So square root of 4 is 2. That's it. No calculation. So do all these activities and let me know if you have any problem with any of them. And let me know before you take your quiz. Keep in mind you can take your quiz twice and Blackboard will select the highest number. A population, again, has 5 scores. SS is 40. What is the variance for this population? So you see, now you got to go back and look at that formula. So you have a SS and your DF is 4. Right there. Variance. Right there, SS and N. So, okay. It's a population, so SS divided by N. This is a variance. 40 divided by 8. If it says what is the standard deviation, then the square root of that. And that one is the same. Because one of them says sample, one of them says population. Keep in mind, like number 4, it says sample. N is 5, and it says sample of N is 5. 3 says population. So the difference is when it's sample, SS is divided by N minus 1, which is DF. So 5 minus 1 is 4. But the top one It's not. It's just 4 divided by 5. 40 divided by 5. Look at the formula and you will see. So you can do those. So these are pretty much all those formulas that we talked about. Some examples that you might have for your quizzes, for this quiz, to just kind of use your spatial ability, find out what's it all about. It says, suppose you earn a score of 54 on exam. Which set of parameter would give you the highest score? So your score is 54. Okay, you have 3 sets of data. Okay, and you have to select A, B, C, or D. Okay, think about it. Your score is 54. The mu red means mean of the class. If your score is 54, would you better off if the mean for the class is 50 or 54? So you see, of course, if if mean or average the student get 50, you'll be better off because you're above the mean, above the average. So you select automatically A or B. Now we have to deal with standard deviation or variance, same thing. That's just the square of that. Now which one you'll be better off? Well, as you can see, that distribution I have, if you use the smallest standard deviation or variance, that will put you further to the right. 2 standard deviation, because it's just standard deviation is 2. So 1 and 1 here, and 2. Each standard deviation is 2 points. So it puts you 2 standard deviation above on the right side. That's good. About the what? About the average guy. That's what the mean is, average. Even though your score is 54, but you still 2 standard deviation above the average guy, average student. But if it's just standard deviation is 4b, then that puts you only 1 standard deviation above the mean. So you'll be better off, of course, with the A. You can guess this one yourself, even though that descriptions are there too. It's the same thing. Other thing, question in your quiz will be, for example, this one, number 4. Which of the following deviation means distance of the score from the mean. So which one of these score is furthest or farthest away from the mean? Whatever the mean is, of course, the one with the highest number, it doesn't matter, negative or positive, puts you the furthest or farthest. We don't know what the number is, but we know that this is x. This is the formula, x minus mu. This is your deviation. So that score, whatever it is, minus the mean, whatever it is, it gives us these numbers. So by just looking at them, which one will be farthest away? Of course, the largest number, which is 8. And it tells us it's going to be on the left side, negative 8 point. And 1 is the closest to the right of the mean. The mean, right, that thick red line. 1 is only one deviation, okay? And then again, -8 is way at, to the left. And this is the same thing, So pay attention. If you pay attention, you realize this is extremely easy. It's just the statistic really is about concentration. At least 50% of it. You got to pay attention, see what it's saying. Anyway, so that's why we have SPSS. If you haven't got your SPSS, I got mine. I just send the email to AU Albizu Desktop. Desk Help, Albizu Desk Help, or Help Desk, or something like that. So, Albizu Help Desk, or if you just contact Rudy, or the other guys, and just let them know you're taking this course and you need a copy of SPSS. They send you the information, the license code, and the instructions, so you can download it. It took me like maybe 20 minutes to download it in mine, so I get a new version, which is 31st. It's the latest, and it's very nice, and you're gonna love it too. So now, this is your second SPSS assignment. All the SPSS assignments are in Blackboard. As you can see, this is a bunch of non-dichotomous variable. Well, dichotomous means two. When your scores consist of just two numbers, pass, fail, 0, 1, 0, 1, 1, 2, 1, 2, 1, 2. But non-dichotomous means more than two. So keep in mind, let's say we have 10 people here, and then you have 5 items. You give them 5 essay questions, and these are their scores out of 5. The maximum, like the first person 1, first question got 5, second 5, then 4, then 3, and 2. And then it's the total. And then all of them, you can read those numbers. These are, again, you got to give them life. They're not just random numbers we throw at there. This is from your test construction course. And so we got these 10 people. Now, the question is, again, we can do this at very large scale. Like we can have hundreds, even thousands of people, and we can have hundreds, even thousands of items or questions. The thing is, at the bottom it says item mean. It gives you the mean for each question, and then, most important, item variance. Those numbers, 2.5, 2.4, 1.8. So by just looking at them, whether you got 5 or 6 or 5,000, if you wanted to select or discard some of these numbers, you discard those items with the lowest variance. That variance tells us about quality of items. So with the low variance, you don't need them. And keep the one with high variance. That's how we relate these statistics with test construction and research. Try to make a meaning. How do we do this? You open, it's called data entry. You enter your data. You open your computer, your SPSS, and you go to variable view, click on it. It's always the same. And instead of item, you write Q as a question. Q1, Q2, question 1, question 2, question 3. So you just write in the first, right there, these are your questions. let's say put 6, add one more to it. 6 questions, and then you click on data view at the bottom left, and then you will see that all those 6 questions, Q1, Q2, Q3, Q4, 5, 6, they on top. So you enter your data, your scores. Like you can see, there's 10 people, and this guy, number 1, scored 5, 5, and the question 1, 2, and then 4, and then 3, and then the second person, people, that first column, the blue one, those are your people, 10 of them. And then the question are Q1 is their scores on question 1. Again, like the first person did 5 out of 5, and the sixth person did 1 out of 5. This is how you read this. But again, we wanted to calculate the variance. We wanted to, let's say if you want to take one of these questions out, which one would it be? The one with the lowest variance. So let's do it. You click on Analyze, always on top. Click on the Scale. Click on Reliability. Oh, so this we can calculate the reliability also of this test. Is the test with 5 items, 5 essay. So this is how you calculate the reliability of it. You go to Analyze, you go to Scale, click on Reliability, and SPSS always give you more options. At this stage, we don't need them, but you can click all of these things if you want to. Scales, mean, median, variance, standard deviations, and all that. All this stuff you see. And then types of reliability. That we use is Chromebox Alpha, or just Alpha. You can see right there in blue. That's by default there. Chromebox Alpha is the best measure of reliability because you can use it for essay questions or multiple choice dichotomously scored or non-dichotomously scored. That's why we leave it there. But if you click on that little arrow, this is alpha, you will see at least half a dozen of different type of reliability. And they all do the same thing, but different purpose. So you close that, continue, and then you close OK, click on OK, and here you are. And here you can see pretty much everything. The reason I don't make this full screen, because somehow when I change the slide, it doesn't change and for you guys. But look like we need to make this full screen. So again, that tells you n number of cases, 10, 100%, everything was there. Number of items, 6, and then Chromebox Alpha right there is 0.868, which is good on a scale. This is proportion from 0 to 1. 0.86 is good reliability. It has a good reliability. So if you create your own test or questionnaire, this is how you calculate the reliability of it. And then the mean and the standard deviation for your items. Let's see what else we have. Once again, the slideshow. And you got the variance here, the second column on the right for each. So you can go through it, select the item means, item variance, and then it has a Chromebox alpha reliability for each question. That last column, last table in black. And then at the very bottom, that small table, that tells you the variance for your test, for your all of them, total variance, which is good for the test, for all of those questions, total variance. Let's see what else we have. A slideshow. Also, if you did range, minimum, maximum, sum, mean, standard deviation, and also all these are your variance. You can see them, the last column. So the lowest is 0.444. So you get rid of that. That's very low. So you keep the others. The 2.7, 2.3, 2. And 1.5. That's how you know. That was question 3. It's low grade. And that's for that. Another thing you need to know is if you have like a score like X1, if I give you all these numbers, it's all the same. Or X2, all the same. And I ask you, what is the variance here? Keep in mind, variance, just the name suggests, it's about variability. It's about changes in the score. But if you don't see any variability, any changes, they're all even, Steven. Just the same number. The variance is 0. So don't waste your time and do the calculation. It's 0. And once again, we work with non-dichotomous score. This table from your test construction also is the same. You got 10 people, but these are like multiple choice question. Multiple choice are dichotomously scored. That means you either get it or you don't. You either get the point or you don't. So 0 means the first guy, examinee 1, question 1 didn't get it. Question 2, no. Question 3, yes. 4, yes. 5 didn't. So these are dichotomously scored. And at the bottom, again, you can see the variance. And if you want to get rid of one of them, the lowest is 0.16. You get rid of, that's the lowest item in the test. But you can do the same thing, put these in SPSS the way I showed you, and calculate the variance for each and match those numbers, see if they are the same. Again, this is the same thing, 5, 5, 5, 1, 1, 1. I think it's the same. It's basically to tell you that there's no variability, so the variance is 0. Oh, of course, so we did that. But this is the same. If there is no variability, no change, there is no variance. You can read these. You have access to these PowerPoint, so read them. And let me know if you have any question, any concern. And also don't forget to stay on top of the SPSS, because that's mandatory. You have to do that. In real world, for your doctoral dissertation, you got to know how to use SPSS. In the real world, you don't do any manual calculation. It's all about learning these statistical procedure, test the statistics, and use a tool which is called SPSS and apply them to your work, to your doctoral dissertation, etc. So again, you discovered your quiz 2. Please read the sample review question, take the quiz 2 on Blackboard, do your SPSS assignment number 2, and read PowerPoint number 3 for the next session. And then next session will be cover chapter 3 and 5, which is z-scores and basic concept of probability. We'll take care of that next time. Thank you and have a great evening.